Okay, we're at modelling motion lesson number 6. We're going to solve problems where force is dependent on time, or where force is dependent on velocity, or when force is dependent on position. First, let's look at forces dependent on time. We begin by recalling F equals ma. We can write F equals ma as F equals m. Instead of a, we're going to write the second derivative of position. Therefore, acceleration, which is the second derivative of position, equals F on m. In doing so, we could rewrite our left-hand side as dv dt. We follow this approach if the force applied to a particle was dependent on time, such as force equals 18t take 6, where force is dependent on time. We can follow these equations for acceleration to solve our problems. Example 25. An object of 6 kg mass is initially at rest. It is then acted on by a variable force, where the force is dependent on time, where the force time period is between 0 and 10 seconds. Calculate the speed of the object after 5 seconds and distance travelled. State Newton's second law and rewrite. So F equals ma. Now, rewriting that as I did before, acceleration equals F divided by mass. I'm going to write acceleration as the differential dv dt. Set up a differential equation. dv dt equals my force, which is 24t take 18 over mass 6. Therefore, if I simplify, dividing both sides dividing by 6, we're going to have 4t take 3. By integrating both sides, I'm first going to multiply both sides by dt. And if I take the integral of both sides, the left-hand side is going to become v. The right-hand side is going to become 2t squared take 3t plus the constant. Calculate the constant of integration, where the time 0 velocity equals 0. Now, if we sub a 0 in here and here, the constant is 0. Hence velocity is 2t squared take 3t. Sum of velocity at 5 seconds, I can sub in 5. That's 35 meters per second. I want to then work out how far it's travelled for the first 5 seconds. That's the definite integral of velocity between 0 and 5. If I do that, I'm going to then raise those powers using the power rule. So that becomes a 3. We're going to divide by that 3. Negative 3t becomes negative 3 on 2t squared plus our constant number 2 between 0 and 5 seconds. Evaluate that. It's 45.83 meters. It's travelled in the first 5 seconds. This time, I'm going to look at where a force is dependent on velocity. So, example 26. An object of 6 kg mass is initially travelling at 4 meters per second. It is then acted on by a variable force, which is F equals 18 lots of v plus 5 newtons. So velocity this time. Develop an expression for x in terms of t. State Newton's second law and rewrite. So F equals ma, or F over m equals a. And as a becomes dv dt, I can write dv dt equals F on m. To set up a differential equation, I have my dv dt, which is acceleration, equals my force divided by mass, which is 3 outside of v plus 5. Let's separate the variables. This time, I'm going to multiply both sides by dt and then divide by 3 outside of v plus 5. Now I have my variables joined together. So my dv's are with my v's, and I've got the dt on the right-hand side. Integrating both sides, our right-hand side is going to become t. What's our left-hand side going to become? We've got the 1/3 of 1 over v plus 5, which is a natural log. So 1/3 natural log of v plus 5 plus our constant equals t. Calculate the constant of integration. Given t equals 0 and v equals 4, I'm subbing those values in. So 4 and the 0. Therefore, I've got c equaling negative 1/3 of the natural log of 9. Apply log laws to simplify the right-hand side, left-hand side. So here, I've got my function, 1/3 ln v plus 5 plus this c value. So I write that, time equals my initial 1/3 natural log of v plus 5, take my constant integration. I can see 1/3 happening in both parts here, so I'm going to factorise that. And subtracting logs is then division, so v plus 5 over 9. I can now express this as a function of time by multiplying both sides by 3 and taking rise this to the e to the power of 3t equals v plus 5 over 9. Multiply both sides by 9 and subtract 5. I have velocity as a function of time. Integrate to determine position. So if I integrate this, the integral of 9e to the 3t take 5 dt, we're going to divide by 3, so 3e to the 3t, and raise negative 5 becomes negative 5t. Given it x equals 0, our time was 0, I can calculate C2. So we sub in a 0 here, and then sub in 0 for t. I'm going to have negative 5 times 0 is 0. E to the power of 0 is 1. So I'm then going to have 3 plus C2 equals 0. Hence, that's why C2 equals negative 3. Take the final model. Position as a function of time is 3e to the 3t. Take 5t, subtract 3. The next section is forces dependent on position. I've focused on this one here, v dv dx. A particle of mass 7 units moves in a straight line, and at time t, its position relative to a fixed origin is x, and its velocity is v. If the resultant force is 14 plus 21x, and v equals 4 when x equals 0, calculate v when x equals 5. So first of all, Newton's second law, which is F equals ma. Our force was 14 plus 21x. Our mass is 7. Rearrange. Our acceleration is 14 plus 21x over 7, which is 2 plus 3x. Now, I'm going to rewrite A as being v dv dx. So here, A becomes v dv dx because I've got a right-hand side in terms of x. Hence, if I separate the variables, we're bringing this dx over here to the right-hand side. I now have v dv and 2 plus 3x dx, which means which I've separated the variables, I can now integrate. Integral of v is going to be a half v squared. Integral of 2 plus 3x with respect to x is going to be 2x plus 1.5x squared, plus our constant of integration. In terms of the constant using the initial values, velocity was 4 when position was 0. So if we sub in our v being 4 and our position being 0, c equals 8. Hence, we have half v squared equals 2x plus 1.5x squared plus 8. Calculate v. So what does v equal when x equals 5? Let's sub in a 5 for x. So substitute 5 in for x. Then have my right hand side being 55.5. If I multiply both sides by 2 and take the square root of both sides, the velocity is plus or minus root 110. Time to celebrate. That concludes our studies of motion.